Hi friends, this is probability and stochastic process. I am Smith and this is homework 10 question 2. And in question 2 we define the following processes, and the first is WSS process, that is wide sense stationary. So let's try to define WSS. And WSS, it says that a real stochastic process is stationary in the wide sense if the value I mean the average value the average value or the mean value is a constant and the autocorrelation function depends only on T1 minus T2 only. So if a real stochastic process has a constant mean value and the autocorrelation is just the function of T1 minus T2, then it can be said as a wide sense stationary process. Now let us try to look at another process, that is independent increment process. Independent increment process. This definition is quite simple to understand, that if a process whose increment depends, let's say does not depend on the previous time intervals, so it's just a function of the present time interval, what's happening in the present time interval, that it just deals with the values of the present time interval, and it's nothing to do with the past intervals. So the third process is a Markov process. This is a very important and very easy to understand, that if the past has no influence on the future, if the past values has no influence on the has no influence on the future statistics of a process, and the present has to be known. So if the present is known and the past has no influence on the future statistics, then it's known as the Markov process. The next process is a normal process, the most basic process that we deal in the stochastic process, that let's define it in this way. A process x of t is a normal random variable. A process x of t is normal. It's said to be normal if the random variables is normal if the random variables xt1 to xtn are jointly normal. Jointly normal for any t1 to tn. Such a process is known as the normal process. And the another one is strict sense stationary process, SSS. So strict sense stationary process is simply the process whose density values does not change with time. Is strict sense stationary process. This is just the basic definition for the strict sense stationary. The next one is white noise. So the process now, let's say v of t I at any ith instant, if the value let's define it as a function x at time t I and x at time tj, if those values are uncorrelated, that is ct of I comma t of j is 0, there is no correlation between the value at time ti and tj, and the correlation is 0, then such a process is known as a white noise. And then the process is a white noise. And the next is mean ergodic. Process. Let's define the mean ergodic process. This is quite a simple process, that if a single sample value gives all the information about its statistics, that if all the statistics let's say a stochastic process x of t is ergodic if all of its statistics are, yeah, statistics means the statistical values, sorry, this is a wrong spelling, statistics. So if the statistics, if the stochastic process x of t is ergodic, it's one sample can give us all the information about its statistics, that we can determine all its statistics from a single sample value. And such a process, such a stochastic process, can be said as a mean ergodic process. So this was homework 10 question 2 of probability and stochastic process. Thank you.